Okay, so in this video I'm going to talk about composition of matter. So it said that chemistry is the field of study concerned with characteristics, composition, and transformations of matter. So I talked about characteristics, properties, changes, that sort of thing, and that falls under transformations as well. Now we're going to talk about the composition of matter. So I'm going to break it down into some categories. We're going to classify it now into different types of matter. So we're going to first break matter up this way. So I've got matter as a big heading. Everything, all substance in the universe classifies as matter. And then we're going to break it into pure substance and a mixture. So basically, all matter can be broken down into either pure substances or mixtures. So what a pure substance is it's a single kind of matter with a fixed composition. So, and you cannot separate this out by any physical process. So pure water, and I should clarify, we don't encounter pure substances very much. To have actually 100% pure water is pretty rare. You'd have to do a lot of purification in a lab. It'd be very difficult. But this literally means that there is no other substance other than water. So you can't break water down into anything else by any physical means. So in other words, in a pure substance, you have one kind of chemical composition. It has a fixed composition as well as a fixed set of physical and chemical properties. If you could literally take water and purify it down to just pure water, and have literally not a single molecule or a single atom of anything else other than water in it, then water, no matter the source, would be the same. What makes water different here and there and from various sources is the other stuff, the other contaminants in it. But if I could get actually pure water, it would always be the same. So a pure substance is just one thing. So pure oxygen would just be oxygen gas with nothing else in it. So it's one kind of substance. When we get to talking about chemical formulas, you've probably seen things like this. Like for water, this is a familiar one. Water is H2O. If I can write the substance with a single formula, like H2O, then it's a pure substance. Or just O2 for oxygen gas. What a mixture is a mixture is a physical combination, specifically a physical combination of two or more pure substances. So, it's important to know that each substance retains its own physical identity, or its own chemical identity. It has a variable composition that can be separated by physical means. So let's talk about all these things. I'm going to use an example of salt water. So salt water, I'm going to take water, I'm going to dissolve salt in it, and you might see salt sitting at the bottom, but if I mix it up, right, then what it looks like is it looks like water. You can't see the salt. It's totally dissolved in there. It's all mixed in. But what's important to understand is that the water molecules and the salt are still there, and they're still intact, and they're not chemically bonding in any way. One way you can tell that they're still there and they still have their own physical and chemical properties is if you drink salt water, what does it taste like? It tastes like water and salt. The salt is still in there. Additionally, depending on how much salt I put in there, so if I have 100 milliliters of water, right, I would get a different salt water solution if I put 30 grams of salt or 50 grams of salt. One would taste saltier, one would have a different density and a different freezing point, and so they'd be different based on their composition. And this is what I mean by variable composition. Pure water is always just pure water. It always behaves the same because there's only one thing in there. You get variations when you have a mixture. again, I want to clarify that the things in a mixture are not chemically bonding together. They're still separate. They're just hanging out together. Finally, they can be separated by physical means. And this may not always be practical, I should say. I'm not saying it's always practically separatable by physical means, but it is separatable by physical means. Because what's going on is if you think in a mixture, so let's talk about a pure substance real quick. And I'm just going to draw the molecules as single dots, or just not dots, as these circles. A mixture is, and then different dots, or different circles, right? But they're still, and I could even have a third thing in there, it doesn't matter. My point is they're not bonded together. I could still pick them apart. I could grab this one and pull it out. I could grab this one and pull it out. I could grab the blue one and pull it out. In other words, we can separate them physically because there's no bonds between pure substances in a mixture to break. So it can theoretically be separated by physical means instead of chemical, because I don't have to break any chemical bonds between them. Now, in the case of salt water, let's see if you can think of a way to separate it by physical means. That's right, you boil the water. So if I had salt water and if I put fire underneath it, I'll boil the water all the way, and what I'm left with is if I can recollect the water through some sort of condenser, I'd have the water here, and then I'd have just the salt left over in the bottom. And I'd have separated them without damaging them or changing them. Okay, so mixtures, as I said, can be separated. And this is all stuff I just said, so I'm going to move on. Okay, so now we have classified matter, as either pure substance. They can be either pure substances or they can be mixtures. Mixtures actually come in two types. So we can further break down mixtures as homogeneous and heterogeneous. So the prefixes homo and hetero have very specific meanings. Homo means same, hetero means different. So what we mean here is we mean that mixtures can either be the same or different, and I'll explain how. It really has to do with how finely they're mixing together. So actually, I'm going to talk about heterogeneous substances first so that I can talk about homogeneous after that. So if I have two things like water and sand, right, they don't dissolve the way water and salt do, right? You're just going to have water and then sand all sitting at the bottom. The sand's all collected together. The water is sitting up here. Or oil and water, right? You might have oil and water where you'd have the water up here and the oil down below, right? They're still mixtures. I should clarify that they're still mixtures. They're just heterogeneous, right? They're different. They have two different parts that are different. That's a heterogeneous mixture, right? They basically are separating out in big chunks, right? They're not mixing up real finely, right? But a homogeneous mixture mixes together so well that they're still physically combined. I don't want you to have any illusions. It's still exactly like the heterogeneous substance in that they're still, because here the oil and the water aren't chemically bonding. In a homogeneous mixture, they're not chemically bonding either. It's important to understand. But what's happening is they're just blending together at the molecular level instead of separating into big layers, right? Still, what you have, if you have salt water, or if you have some other substance like water and ethanol, alcohol, so if I've got water and alcohol, right? They mix together, and to our naked eye, and this is really the division between homogeneous and heterogeneous. It's whether it separates out visibly to the naked eye, right? I can't see in here the different water and alcohol parts. But if I could zoom in submicroscopically and zoom way in, I would see water particles next to alcohol particles, and they're not bonded, they're just mixed up, right? They're just mixed in with each other, just like the water and the oil. It's just that they divide up more finely. Really, when it comes right down to it, the difference between a homogeneous and a heterogeneous mixture is, can you see the separation? Is the separation big enough to see? If it is big enough to actually see separate layers or parts, it's heterogeneous. Hetero meaning different, referring to the different parts. Homogeneous is mixed up so you can't see. Now, actually, I'm being a little disingenuous here with milk specifically. Some of you may have knowledge of this greater than my own, where I'm actually talking about homogenized milk or homogenized milk. I'm a city boy. I'm used to getting my milk in the store, so that's what I'm used to seeing. But most of you know that it actually, when you get it out of the cow, it separates into layers, which is actually a heterogeneous mixture. So, oil and water, oil and sand. Sand itself is a heterogeneous mixture. So, here's some homogeneous mixtures. One that I want to show you actually here, this metal, this is brass. Brass is a mixture of copper and zinc, I believe. Copper and zinc that have been melted into liquids, poured together, and allowed to freeze again, or allowed to solidify again. And so the result is a solid that is homogeneous. You can't see the copper and the zinc separately. They're all next to each other. But they're not chemically bonded, it's important to say. I could, if I had a hot enough furnace, I could boil one of those metals off. Heterogeneous mixtures are visibly different. So like curds and whey here, and sand. You can see the individual little particles of sand. So I want you guys to tell me. Now, sometimes in these problems, there's maybe a bit of a room for argumentation here. So what's important is I just want you to understand it conceptually. So mouthwash, I've never seen heterogeneous mouthwash. I don't know if people have some sort of weird Goldschlager mouthwash or anything, but you might have some strange mouthwash. Usually it's homogeneous. A whole watermelon. A whole watermelon is definitely heterogeneous. It's got the rind, and then the pulp, and then the seeds, and all that. Peanut butter. Now, this totally depends. Let's see what I was thinking of when I put it down. Now, obviously, I was thinking chunky peanut butter, because I don't like creamy peanut butter, but creamy peanut butter would be homogeneous. It totally depends on the peanut butter, so that's maybe not a great question. A bronze chain, as I just said, bronze, brass, these are all alloys. Homogeneous. Okay. Now, remember, we had matter. We have mixtures over here. And we have pure substances. Pure substances can actually be broken into two categories as well: elements and compounds. Now, there's actually an interesting analog. There's sort of an analogy between elements and compounds. There's a similar relationship between elements and compounds as there is between pure substances and mixtures. So where pure substances and mixtures are talking about substances, so a pure substance is, we're talking about the physical separation, right? A pure substance is one substance. A mixture is two substances physically mixed together. So their relationship here is physical. The relationship between elements and compounds is chemical. Right? So, what I mean by this, let me get rid of all this here. What I mean by this is there are elements and then there are compounds. Elements are, an element is a pure substance that cannot be broken down into simpler substances by ordinary chemical means. So right? Pure substances can't be broken down by physical means, but they may be able to, maybe or not, be broken down by chemical means. Elements cannot be broken down into simpler or more substances by chemical means. So, gold, copper, silver, carbon, oxygen, even oxygen, which is, its symbol is O2, it can actually be broken down into 2 oxygen atoms. However, it's still just oxygen. I don't get anything out of it, right? So anything that's on the periodic table is an element. I think my link is broken, but you can look up the periodic tables in the front of your book. Any of those substances are all elements. We're going to talk about elements a lot in this quarter, in this class. Compounds are so understand that these both, elements and compounds, are both pure, they are pure substances, right? You can't break them down physically. But compounds can be broken down by chemical means, right? They can be broken down into simpler substances by chemical means. Because water, H2O, right, it's a pure substance. Because it's only just water, right? And though the hydrogens and the oxygen are bonded together chemically, and then you have a whole bunch of water molecules hanging out together, right? So by physical means, I can't separate this out. But if I break the bonds up, I'll get out hydrogen and oxygen. So fundamentally, a compound is just a pure substance that has 2 or more elements in it. So anything that's written with just one element, C60 or just xenon or whatever, and I put those really close together, or just xenon, those are elements. Anything that's got more than one element in it, like CO2 or H2SO4, anything like that, that's a compound. And a mixture has to be shown by at least 2 different formulas. So, right, so a mixture, kind of going back and talking about mixtures a little bit, a mixture, we can have a mixture of hydrogen gas and oxygen gas, right? But I'm not putting them together, because when you put them together in the same formula, it implies that they're chemically bonded, right? So I have an element hydrogen, I have an element oxygen mixed together. Physically, that's a mixture. But hydrogen and oxygen mixed together chemically is the compound water. Here is a better image than I could draw that breaks it all down. And I will talk about elements a little bit more in the future.